All right, here we go. Let's go through all this. And review all our points of concurrence, how they're formed, and what I should know about them. Because I'm not going to give you any more. This is it right here. All right, this is it. All right, let's start with the perpendicular bisector. I'm not really too concerned about the description of it. All right, what I'm really concerned about is the diagram. So can you guys draw yourself a triangle for me, please, in the example? I don't care what the triangle looks like. Now, I want to make this very, very clear. This is the only one out of the four a vertex. A vertex. Perpendicular bisector does not. Okay, but it does have to go through the what of the side? Midpoint, and it's got to be obviously perpendicular. But again, and I prefer you draw one where it doesn't come from the vertice. I'll do my best here. I'm going to keep it. I don't care if you don't like it or not. That is perpendicular to it. My stress here is it does not have to come from a vertice, but should be perpendicular. If I drew the other two in, they're all going to intersect at the same point called the, oh, I'm hearing different words. I'm getting nervous. All three perpendicular bisectors intersect at the circumcenter. Yep. And you may just want to make a little note. What I expect you to do is find it on a graph. Okay, find it on a graph, specifically a right triangle. Okay, we don't have enough time usually on tests and quizzes to find it on something that's not a right triangle, but find it on a graph given a right triangle. All right, given a right triangle. And we've done a couple of those already, one for homework, one in the notes. All right, and what should I know about it? The circumcenter. What do I know about the circumcenter? What's the special fact, property I should know about it? Equidistant from the vertices. Yes, equidistant from the vertices. All right, equidistant from the vertices. All good. Angle bisectors. Draw your triangle again. Show me an angle bisector with the correct markings on there. And I know I already have it on there, but if I drew in the other angle bisectors, that would be called the what, where they intersect? In center. I would expect you to construct it. I know graph, but I would expect you to construct one. All right, so I give you paper and say construct the in center. You guys give me two angle bisector construct. Is your pretty about an in center? Equidistant from the sides. And then yesterday we went over this new concept called a median. So everyone draw another triangle, please, in the example box. Where's a median start? Any vertex, and goes to the what of the opposite side? Midpoint of the opposite side. Medians go to midpoints. Come on, let's not start this. There we go. And what's the special? Oh, I shouldn't. All three medians drawn in intersect where? Centroid. What's the special fact we learned yesterday? Breaks the median into 2 to 1. I would expect you to find this on a graph. And what we're going to do today is we're going to find the centroid algebraically. So on a graph and algebraically. Any questions so far? And the last one in altitude. Where's an altitude start? Altitude starts at a vertex and is what to the opposite side? Perpendicular. And if I drew in the others, where would they intersect? Orthocenter. And remember, there is no special fact to know about the orthocenter. But I would expect the following, though. If I have an acute triangle, where's the orthocenter located? Inside of a right triangle. If I have a right triangle, where's my orthocenter? Where the two legs, because remember, these legs are also what? Altitudes. Legs on a right triangle are also altitudes, so where they meet, this point right here is the orthocenter. And what if I have an obtuse triangle? Over one time, today's going to be more on the centroid. Here, going. One of them in our group right now. So if you go to today's notes, go ahead and graph that triangle if you haven't already. And here's your assignment, you and your group, in the next 5 minutes. Can you find the centroid of that triangle? Before you get going, let's just talk quickly. Centroid. I need to find at least 2 what in that triangle? Medians. Medians go to where? Midpoints. Yes, there's straight edges up here. If you need a straight edge, draw that median in precisely. Talk it over in your group. Make sure you know what 2 sides you're going to find. And then we'll talk about 5 minutes. Go in here. The median problem. All right, all groups are running into this problem. And that is, there's no idea what that centroid is. I know it's located, but I couldn't tell you an exact point because it doesn't hit an intersection point of the x and the y axis. Everyone agree there? That stinks because I asked you for the centroid and not getting it. First of all, is everyone all right with my two medians up there? I found the midpoint and drew it from the opposite vertice. That's my first concern. We can at least do that so that you are in this predicament where you have no idea what the centroid is. We're all in agreement? Everyone at this point. But everyone has it around the same spot that I do up on the board. All right, but are we all in agreement? No idea. I could maybe guess, maybe a half on the x-axis. I don't know. I have no idea, but I'm not going to guess it. All right, so we need another way, and that's today, is how algebraically you can find this centroid. All right, and we're going to use it. We're going to find it what we call partitions. Dividing a line segment into so many congruent parts. So everyone ready to go? All set with your median. All right. Now, how can I do this using this thing called partitions? Well, to remind me from yesterday, this centroid that we're trying to find is going to divide the median up into what ratio? 2 to 1. Yep. 2 to 1. Which means if I'm going to break it up into a ratio of 2 to 1, anybody figure out how many equal pieces I want to cut this median up into? How many? Not bad. 3 equal pieces. And yes, you just get that from the 2 to 1, gives you 3. So now I just want to give you a visualization of what we're doing here before we get to the actual algebra behind it. So I have a segment, I have a median up here. All right, one of the medians from the triangle. And I broke it up into 3 congruent parts like you told me. I'm trying to find the point that breaks it up into 2 congruent pieces. This point right here breaks it up into what? 1 congruent piece to 2 congruent pieces. I don't want that point, do I? This point right here breaks it up into what? 2 congruent pieces to 1. So I'm looking for this point right here. We okay on now what we're about to do? Yes, no, maybe? Or how about we just get to the algebra part of it? Okay. We're going to do the x-coordinate and the y-coordinate separately for this. All right, the x-coordinate and the y-coordinate. First thing I need is we need to focus on one and only one median right now because there's 3 going on. So what I'd like you to do, if you did not already, find the point of BC, please, and call that point D. So if you did not do that on your own, please find the midpoint of CB, and we'll call that point D. Everybody have point D? Everybody here in a second. What is the midpoint of CB? What is that midpoint of CB? Here you go, 17. What did you find the midpoint of BC as? Yep. 3 point. Yep, that's point D. Where did this median start from? Point. The median start from point. All right, so all I'm focused on is this median AD. And what I need your help with is I need to break it up into 3 congruent. Looking for what the point is, because it's my centroid. We all agree that's going to be my centroid. All right, so I'm going to start with x coordinates first. All right, point A had an x coordinate of what? -5, right? And I went to where for point D? Did Teddy just find us the x coordinate is on the midpoint? 3.5. So I need your help and your I travel on the x-axis. I travel a total of 8.5. That line segment, that median AD is 8.5 units. And you guys just told me, how many parts do you want to break it up into? 3. So I got to take that 8.5 evenly by 3 congruent parts. Along the x-axis, if I broke it up into 3 congruent parts, what's the distance for every part? Is there? So about 2.83 we're getting, right? All right, so let's see if you can figure this one out. So that means every time I want to break it up evenly, you have to travel how many units on the x-axis? 2.83. So ready? As I go from A to this point, it's going to be 2.83. But do I want this point? No. So do I want to go 2.83 units? No, I want to go another 2.83 units. So not only do I want to go 2.83, but do you see why now I need to multiply that by 2? Because only going by 2.83 is going to get me here. I need to go by another 2.83. So that's why I'm multiplying it by 2. So you guys, can you help me with the total distance I need to go? So about 5.66, right? 5.66. So if you want to get to the centroid, that 2 to 1 point, I need on the x-axis to travel how many units? 5.66 from where? Where did I start at on the x-axis? -5. So from -5, come on. Sorry, guys. Try that again. Maybe. There we go. So from -5, I need to go 5.66 units. And where do I end up with on the x-axis? 0.66. And that's about, and I don't expect you to change it if you don't want to, or about 2/3 as a fraction. Yes, Emma. Most time, this is probably the only one where I'm going to have you round. Okay, usually they'll come out to be nice, clean numbers. It just doesn't happen in this one. Okay. Look at where your centroid is on your graph right now. Is this a pretty good estimation for on the x-axis? About 0.66, 2/3. Yeah, we're in the ballpark. Everyone agree? Yeah, we're in the ballpark. Okay, so there's your x coordinate of the centroid. Now let's find the y coordinate. We're going to go through the same steps again. And I know this may seem a little confusing right now. Just stay with me. Here you go. Y-axis now. Where'd you start? Y-axis. 0. Point A's y coordinate is 0. And we travel to where? Where on the y-axis? What's the y coordinate for point D? 3. So that's a total of 3 units. Oh, this one's nice. Yeah? Because how many parts do we have to break it up into?
3.
Beautiful, huh? 3 divided by 3. So that tells me every 1 unit will break it up evenly. But do I just want to go 1? No, because that's only going to bring me to the 1 to 2 point. I need another one, so I'll multiply that by 2. So I'm not going to go 1 unit. I'm going to go 2 units from my starting point, which was what? 0. So 0 plus 2. Where did I end up at? 2. So let's put the 2 together right now. What is the coordinate of the centroid? The coordinate of the centroid? What was the x-coordinate we found? 0.66 or 2/3, comma. Check that on your graph. Are we pretty much there? 2/3 up 2. So we're just going to find the distance we're going on the x and the y, divide that distance by what we're breaking it up into, because it won't always be 3, and then multiplying it by how many times we have to go. We're going to get a lot better at this right now. Anything you want to ask right now? Anything? Because I want to at least get through the next couple examples that I have you do. Anything right now? Because the numbers are going to come out to be a little bit more clean, I promise. Yes, Emma, go ahead. Okay. My A coordinate. What was the y coordinate on A? So I started at 0 on the y-axis and then ended up where for point D? What is it? No, for point D. Right? We remember at the beginning we found the midpoint of CB as 3.53. Right? So I went from 0 to 3 on the y-axis. 0 to 3, and I cut that up into equal parts of 3. Good? Okay. Anybody else? We good? Because now I'm going to turn to you guys. Let's roll. Can I do this using other ratios other than 2 to 1? You're darn right. All right, the centroid is really not my focus today. It's other ratios. So I have point A and point B. That's a directed line segment AB. I'd like you to partition it into a ratio of 2 to 3 now. 2 to 3. So now we're not going to break it up into 3 congruent parts. We're going to break it up into 5 congruent parts. Yes, that 2 to 3 tells me, hey, break this up into 5 congruent parts. Ready to go. Deep breath. X coordinate first, as usual, X coordinate. All right, let's open it up to you guys now. 8. Who's got 8? Okay, ready. Where do I start on the x-axis and where do I end going from A to B?
You start at -3.
I go from -3 to where? To 2. Everyone agree? -3 to 2? How many total units am I going?
5.
Yes, 5. I love that because I'm doing it 5 congruent parts, right? It's always nice when those numbers are divisible. All right, now let's go to that. That distance of 5, you're dividing it by what I need to cut the line segment up into, which is 5 congruent parts. So that means every time I cut it up, I'm going to go 1 unit. Now, here's where kids forget and struggle. You're going 1 unit every time, but I need to break this up into 2 to 3. So how many times do I need to move here? Twice, that first number. So you're not going to move 1 unit. You're actually going to move a total of 2 units. Yes. So I'm going to take that 1 unit, multiply it by 2, because I'm going, do you see why I'm going twice? I need to get, because if you just did it, where's, let's go to the backboard real quick. Here you go. Hey. A, B, oh boy. So they're 5, all right? Congruent. You got it. 5 congruent. If you only went 1 unit, you're going to get to that point, which only breaks it up into what? 1 to what? I don't want that one, do I? I want this one, which breaks it up into. So does everyone see why I'm adding 2 and just not 1? We're good? All right, perfect. All right, so let's do that. Now remember, that's not where you end. You got to go back to your original starting point and say, all right, what was my original x coordinate I started with? -3, and I'm going 2 units. And where do you end up on the x-axis? -1, yep. Okay, can you help me do the same thing for my y-axis now? Y coordinate now. Number 1. Where did I start and end on the y-axis? -0. Okay, sorry about this one. I'm sorry, because how many total units am I traveling? 4 units, sorry. Because you got to take that 4 and divide it by 5 that I'm cutting it up equally into. So I'm actually going to go 0.8 units every time, yep. But how many times am I going to go 0.8 units to reach to this point I need, the partition point? Twice, yep. So 0.8 times 2. I'm actually going a total of how many units on the y-axis? 1.6. Where was my starting point? -4. Add on 1.6. And where do I end up with on the y-axis? -2.4, yep. Put the 2 together. Where's my partition point of 2 to 3? -1, -2.4. That's the point. I'll cut it up. Okay, let's keep it going. Keep it going now. Now we're going 4 to 1, right? 4 to 1. Okay, 4 to 1. Here we go. X coordinate. 1 again. X coordinate. -2 to 2. Yep. How many units is that? 4. If I'm going 4 to 1, I got to cut it up into how many equal parts? 5. Yep. And that's going to be 0.8 units. Ooh, hold up, though. Are you just going to go 0.8 units? You got to multiply it by 4. Yeah, because you're hit that 4 to 1 point. So I got to take that 0.8 and multiply it by 4. And I end up with 3.2. Common mistake I see kids do. They think that's my final coordinate. No, that's the distance you travel from your original starting point. What was my original starting point on the x-axis? -2. So I'm going from -2 and going 3.2 units. So where do you end up with on the x-axis? Where do you end up? 1.2. Okay, do it for the y. All right, let's see who's going to help me out here on the y's. Number 23. What y coordinate do I start and end with? 5 to -3. That's a total distance of what? 8 units. Sorry, everybody. Yeah, I know. All right, 8 divided by 5, what are we looking at? 1.6. I'm going to see if I can catch anybody here and see if anybody's focused. You're still going how many times? 1.6? 4 times. That's not going to change. So 1.6 times 4. Anybody want to tell me the total distance there I'm going to travel? 6.4 units. You better watch yourself here. You better watch yourself. Because if you take 6.4 and add it to 5, yeah. And isn't that above where my line segment even is? You're traveling from what? 5 to -3. So this coordinate's got to be somewhere in between 5 and -3. If you add 5 and 6.4, you're going to get 11.4, which is way off. Everyone see where I'm going there? All right, so I don't actually want to add 6.4 to what I want to do. Subtract it. So 5 minus 6.4. And where do you end up here? Negative 1.4. So my partition point will be -1.2 and now, if you're nervous, you're going to forget maybe I'm always going to never going to remember when to subtract. 5 to -3. You could okay, I'm going down. So you really, I know distances are never negative, but if you want to keep reminding yourself, negative, negative, and that might help you out. Okay? If you want to just say, oh, I'm going 5 to -3, I'm going down there, so I got to make that negative. All right? I'm going to walk around in your group here for this next one. You guys have what, 3 to 7 for that next one? Okay, I will let you know that here's your final answer. You should get out -0.2, 2.2. Okay, go ahead with your group. That's what we should get out. Three to seven ratio. Again, I see some people making a common mistake here. If you're getting 1.8 and 1.2, that's the total distance you have to travel from your original point. So you have to add that on to your original coordinate. All right, that's not where you end up after you multiply it. You do not end up there. You have to apply it to the original x and the original y. We okay here, guys? And hey, I just want to, no, don't pack up. This last one here in the notes, where it says break it up into 1-to-1, that's how many congruent parts? You want me to break a line segment up into 2 congruent parts. This is just another way of me asking you to find the what? Midpoint. Yeah, 2 congruent parts, right? Yep. Okay, I believe the homework's in the packet. Couple problems using a map. Have a good day, guys. Have a good day.